0. So if I have 2 to the 0, it's going to be 1. So any number to the 0 power is going to be 1. Yes?
So can you just say it always contains 1 and B instead
Yes.
of 1 to the B because it doesn't?
Yes, every one will always contain on the graph.
Is that a coordinate then?
This is a coordinate, yes. That is the coordinate on the graph. I'm always going to have 1. I will always have, let me see, 1, when x is 1, y is the 1/3. When I go back to, let's go with x, 2
Wherever it
raised
intersects
to
y.
the x,
Wherever it intersects y is 1 comma b at that point.
1 comma b. That's what it is.
No, that's
1
not what it is.
represents,
Y.
Wherever it intersects 1 is B.
Right.
Where x is 1, y is B.
Yeah.
so right in here, so when x is, let's see if we can zoom in on this. Zoom into, oh, I lost it. I can't see it, zoom out.
Okay.
Well, let's see, where am I? There I am. I could try, well, maybe because, right there. Okay, so, right in here, whatever when x is 1, my b value is whatever my base was. Okay, Haley?
May I go to the bathroom?
Yes. Okay, so.
Why is that?
Think about the exponent to the 1 being a number.
What?
Say that again?
Like something to
Something's
the
2
first.
to the power is always going to be a number.
But why does that make it always there on the graph?
How about when it is 3 to the 1? For each of these, whenever I have, let me see, if I have 2 to the first, it's always going to be 2, right? I'm going to have 1, my x values, this represents x. And so when I graph it, when x is 1, what does that value represent? 2. When x is 2, let's go with a different base. When my base is 3 and my x is 1, what is this equal to? 3. So I can say, if this is b, I will always have 1 and the number. Does that make sense to you? Everybody okay with that? Okay, good. All right. Let me see. What happens when, let me see, what else? Okay. Oh, and the y-intercept, what is b to the 0? B to the 0 will also equal 1. Okay. So, let's move along. What happens, why did we say actually that b has to be greater than 0? What happens when b is less than 0? When the b is less than 0?
But you said it works when it equals 0.
When b, by definition, we said the b cannot be less than 0.
The base.
The base, we have b to the x. Okay, the base is b.
Less than 0, it just makes the graph go upside down. Yeah.
The other one.
It would go upside down. So let's say b is less than 0, and let's have a -2. Is -2 less than 0?
Yeah.
Okay, can I have that to that? Does that work? I have an exponent that is greater than 0? Okay. Can I rewrite this like this? Is this a real number?
No.
By definition, what did we say we had to have? A real number. So that's why b is not going to be B has to be greater than 0, because when it's less than that, we would end up with an imaginary number. Okay. Okay. Quickly. So here's the graph. I'm going to just look at some graphs. So you know that when we have exponential, it's, well, actually, let's go with linear. Linear, if I'm making, I think this is a problem of $5 an hour or $7 an hour. Linear is just repeated addition, right? $7 for 1 hour, plus 7 more for 2 hours, plus 7 more for 3 hours. Whereas if something is raised exponentially, it is multiplied by itself. Okay, and that's just the big picture of the differences. All right. Yeah. I don't remember if we have ever done anything on this formula.
Nope.
Have we ever seen this?
No.
Okay. So, let me just show you. So, Haley, for you. All right, I'm reading this right out of your book. Many real-world situations can be modeled by exponential functions of the form. Okay? And this is going to be, and you need to write this down. This is really important because we're going to use this. Okay. P is the initial amount. Okay, so we're looking for A equals P times B times raised to the T. Okay, P is the initial amount, something that we're starting with. Okay, B is the base that you're multiplying by, okay, over time. Okay. A is the amount after time. Okay? So a classic example would be you put money in the bank, that is your initial amount. You're getting interest 5%, and it is being compounded for 10 years or quarterly or whatever. Okay? So, and then A would be the amount that you have. Now, this one is, these situations include population growth. Something happens initially, and then there's something that happens to it, your base over time. There's radioactive decay, growth of money in a bank account, etc. And we're going to read about one of those.
Wait, what is the rest of that sentence? B is the factor you multiply the amount by.
Every time period.
That's worded really.
It is, but that's what I just said. You just need to know. P is the initial amount. B is the factor you multiply by. And 3, A is the amount you get.
And T is
And T is time. That one makes the most sense. So P is often referred to as principal, the money that you're putting into a bank account.
Wait,
And A is the amount you get after it's been compounded. What?
like I've heard of P equals IRT, right? Like interest
Yeah.
rate and.
Time, yeah?
Yeah.
Yes, we're gonna get there.
Yeah.
All right, we are just doing simple compounding right now. All right, so I hope I can do 2 things with you. All right, this is the end of your notes. You can just listen at this time. Let's see if we can't make sense of this. There we have a formula. What is the formula?
A equals T, B, T.
Okay, and that's your time. So, Bill has 500 in a savings account that pays 5% annually. Write an equation that models the amount of money he has in X years, assuming no deposits or withdrawals.
500.
Then use the equation to find out how much money Bill will have in the account in 4 years. Dan?
You want the equation?
Yeah.
500 times 0.05.
Over X. Okay, there is a slight problem with this. Think about it. Is he losing money or is it growing?
Growing.
So it'd
So
be
he-
500 plus 500 times 20.
No. He has $500.
That's the amount that it does.
Is that 100% of his money?
So it's
Yes.
times
So it'd be
1.05?
And so he's going to get, what, 5% more?
So 1.05.
So one.
So it's going to be 105% will be in his account, or 1.05. So you need to make sure that you remember that things are growing. So you have that money, 5% is going to be in the account, so it will be 105 that you're using. Okay. What, two more things. Okay. I'm gonna solve 64 is equal to 8 to x minus 2. So now we're gonna deal with